Off the coast of Yemen, in the Arabian Sea, there is an island that looks like it belongs on another planet.
Trees shaped like inverted umbrellas rise from bare rock, their canopies flat. Cut into their bark, a thick, blood-red resin slowly weeps out, giving the island's most famous. This is Socotra, a small archipelago that has been separated from the African and...
Depending on which landmass you're measuring from.
In that time, cut off from the rest of the world, evolution here simply kept going, alone.
Today, more than a third of Socotra's plant species exist nowhere else on Earth. Some of its reptiles, birds, and land snails are found only here and nowhere else on the planet at all. Scientists call it the Galapagos of the Indian Ocean, but in some ways, that undersells it. Modern scientific interest in Socotra's unique biology began in earnest in the late 19th century, when European botanists quickly realizing how much of it matched nothing else in their existing records. But real, systematic study of the island's biodiversity didn't accelerate until the late 20th century, when international research of the archipelago's plants, reptiles, birds, and invertebrates. What they found reshaped how scientists understood island evolution entirely. Researchers began mapping Socotra's isolation, using geology as much as biology. Tracing the island's departure from the ancient supercontinent Gondwana, and its long, slow drift as the Arabian Peninsula, leaving Socotra stranded in increasingly open water. Every additional millimeter of separation meant fewer new species arriving from the mainland to compete with, interbreed with, or replace what was already there, turning the island, gradually, into something closer to a sealed laboratory than an ordinary landmass. The numbers researchers have documented on Socotra are, on their own, a form of evidence for just how deep this isolation runs.
Of the roughly 825 plant species cataloged on the island, more than 300 are endemic.
Over 90% of the island's land snail species fall into that same category, an extraordinarily high rate for any ecosystem on Earth. The dragon's blood tree itself is a living relic. Botanists classify it as part of an ancient lineage that has almost entirely vanished everywhere else. A survivor from forests that covered much larger regions of the world tens of millions of years ago. Before climate shifts and competition wiped them out almost everywhere, except this one isolated plateau. Dangerous. Even the island's indigenous language, Socotri, is considered a linguistic relic, an ancient South Semitic
preserved in the same isolation that shaped the island's plants and animals.
Biologically, geologically, and even linguistically, Socotra tells the same story from every angle. This is what happens when something is simply left alone, for long enough, to become entirely its own thing. Here's the part of Socotra's story that surprises even researchers who've studied isolated ecosystems elsewhere. This level of isolation should, by most models of island evolution, have led to far less diversity than what actually exists here, not more. Small, cut-off islands typically lose species over time. Fewer individuals means smaller gene pool.
Somehow, Socotra defied that expectation almost entirely.
The answer, researchers now believe, lies in the island's unusual size and internal diversity.
Socotra is large enough and geologically varied enough to contain multiple distinct microenvironments within itself,
each functioning almost like its own smaller island within the larger one. Species didn't just evolve in isolation from the mainland, they evolved in relative isolation from each other, across the island's own internal landscape, effectively multiplying the evolutionary experiment many times over within a single landmass. Socotra isn't just one isolated ecosystem. Understanding exactly how the dragon's blood tree itself survives on Socotra reveals just how finely tuned this ecosystem has become. Its distinctive umbrella shape isn't decorative, it's a precise survival adaptation. The dense, tightly packed canopy is engineered to capture and funnel Socotra's rare moisture, dew, fog, and the occasional rainfall. The same broad canopy casts deep shade underneath, protecting the shallow root system and any young seedlings from the harsh desert sun. The blood-red resin serves multiple purposes. It seals wounds in the bark against infection and moisture loss, and its strong scent and bitter taste likely deter browsing animals from damaging the trunk. But researchers have identified a serious complication. Dragon's blood trees can live for many centuries, but new seedlings struggle to survive in the wild today.
Largely because free-ranging Nubian goats, introduced to the island generations ago, graze on young saplings before they have any chance to mature.
Across much of the island, ecologists now find groves made up almost entirely of old, established trees,
with very few young ones growing up to eventually replace them. Socotra today faces a genuinely uncertain future, and not only because of grazing pressure on its most iconic tree.
In recent years, increasingly powerful cyclones, but rare in this region historically, but growing more frequent,
Uprooting specimens that had stood for centuries in a matter of hours.
Researchers studying the island's climate now believe warming regional sea temperatures may be intensifying these storms.
Meaning the very isolation that protected Socotra's evolution for millions of years offers no protection at all against. The island was named a UNESCO World Heritage Site in 2008, specifically because of its outstanding, and conservation efforts here remain difficult, underfunded, and complicated by the region's ongoing political instability. What makes Socotra's remaining mystery so uncomfortable is its scale. This is not a single endangered species story. The file is closed. The mystery remains.